To start with the continuation of the first module, which is the IP addressing. So, guys, in the last session, we discussed about the OSI layer and the introduction of the IP addresses, and we have seen the IPv4. So, I have given you one assignment, and thanks for your response. So, we received multiple answers, and today I'm just going to recap whatever we have seen in last session. So we discussed about the OSI layer. So I hope my screen is visible. Please acknowledge.
Yes, sir, visible, sir.
Okay. So we have seen multiple layers, their respective function. So here in the OSI model, we saw that every layer is performing a specific function, like application layer, which create the content, which create the data. So application layers means what? All the applications that need internet. That is the application layer, like a web browsers, email clients, and any other FTP clients or your HTTP clients. Then presentation layer, just convert that content in a predefined format. Session layer, establish, create, modify, delete the session along with the several protocols like SIP protocol, session initialization protocol. Then we saw the transport layer, do segmentation and concatenation, also define the transport protocol layer, which is a layer 4. Network layer, add the logical addresses, right? And data link layer, add the physical address as well as the add some FEC and CRC bits, and then it goes to the physical layer. So here we have seen that data become packets, then it become frames, and then it goes to bits. So this is the vice versa process. So here we saw the comparison between OSI layer and TCP layer, and then we started the IP addressing. Okay. So guys, here I again wish to ask you, if I say there is a L3 switch, so can anyone tell me which layer it is? If I'm saying L3 switch, which layer it belongs to? Anyone? Layer 3 switch. We discussed in our last session.
Network layer.
Network layer or data link layer. So it is network layer device because it's a L3 switch, and L3 switch can read the logical IP addresses. And can you tell me any data link layer device other than switch? Also a physical layer device. Any L2 and L1 device?
Physical layer, hubs, sir.
Hubs. And data link layer?
One is switch, sir.
Okay. Other is bridge. And here a part of the hub, repeater is also a layer 1 device. Okay. Fine. Can anyone tell me layer 2 is a half duplex or full duplex? Do you understand half duplex and full duplex? Anyone? Okay. Let me tell you, there are three types of communication. There are three types of communication: simplex, half duplex, and full duplex. So duplex means which is transmission as well as reception, where we have a separate transmission for transmission, separate path for transmission, and separate path for receiver. So when we say it's a duplex, you can consider it as a two-lane highway where we have two roads with a different direction, opposite direction, and there is a divider in between. So this divider is basically a isolation between these two links, transmission path. So this is TX path and this is RX path. So this is called full duplex. So if something is simplex, it cannot be a duplex. So simplex means, let's suppose there are two nodes A and B. A can transmit, B will only receive, and there will be one connectivity, or I would say the one physical link available, physical path available, right? If you say half duplex, where A can transmit, B will receive at one physical path, let's say this is path 1 and this is also path 1, right? B can also transmit and A will receive at the same path P1. This is my physical path. So here you can say B will never transmit, B will never acknowledge, right? And in the half duplex, B will also transmit but at the same physical path. So it won't be a simultaneous communication. It will be one at a time. So now hope you can understand, in the full duplex there will be A will transmit, B will receive at a path 1, and B can also transmit, A will receive, but this time it is a simultaneous communication because we have a two separate paths. So this is called full duplex. So switch is a full duplex device. So all layer 2 devices are full duplex device, right? Okay. So moving forward, uh, let's talk a bit more about the functioning of switches and routers. So if you talk about the we will continue our IP addressing and subnetting part just after this small topic, which is the type of devices. So if we talk about the switches, how does the switch work? Switch basically works on one concept which is called store and forward. So it is a reliable communication. Also, it is comparatively a slow communication because here it do not do any error checking. It only checks the fragmentation part, right? So here I'm going to show you which part a switch check. So it checks only 64 header bytes and it store and forward the cut through information, right? So that we will discuss here. And if you compare it with a router, so router is a L3 device like a WAN. So as I already mentioned in the last session that one switch is responsible for creating a network, right? While if we talk about a router is responsible for communicating these two networks. So you can compare it with a WAN network, right? So router basically provide the interconnecting between the network, right? And the best example of the WAN network is a mobile network. So a router use a IP address for addressing purpose and it maintain the routing table and it is comparatively fast and it every port has its own broadcast domain, right? So we will discuss today itself what is the broadcast domain and all. So now let's start with our IP addressing part. So yes, in our last session we have seen that there are two types of IP addressing which is very currently we are using IPv4 and IPv6. In the IPv4 part we saw that there are four classes, class A, B, C and D. So can anyone tell me the range of class A? Quickly, please. It's a recap. Then we will start subnetting and IPv6. Anyone just quickly tell me the range of these 4 IP classes? Anyone?
One dot zero dot zero dot
Yeah.
zero to 126.0.0.0.
Just a minute. Just a minute. Okay, please tell me. Yeah, class A. It will start from 1 dot
0.0.0
to
126.0.0.0.
0. And can you tell me the number of network bit and host bit here in class A?
Network bit and 3%.
Sorry,
2 power 8, sir. Network.
2 power 8. So
Yes.
yes, it is my network bit, it is host bit, and it is host bit. So it is 8 bit, it is 8 bit, 8 bit, 8 bit. So I can say network bit is 2 to the power 8, while host bit is 2 to the power 24. Right? Okay. Now tell me class B. Quickly.
128
128 dot
0.0.0
0 to
191 dot
1.255.0.0, and here the number of network bits are network,
2 power 6.
host, and host. So 8, 8, 8, 8. So these 2 to the power 16 and 2 to the power 16 network bit and host bit. Now if we say class C, it is 192.0.0.0 up to 223.255.255.0. So it will be network, 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 and host. So it is 2 to the power 24 network bit and only 8 bit in host. Right. Now if we say class D, that we use for multicasting purpose, the range is 2240.0.0.0, and it goes up to 255.255.255.255. Right? Okay. So guys, who will tell me what is the meaning of default subnet mask? What is the use of default subnet mask? Anyone? What is the default subnet mask? Let me ask to uh, okay. Who will tell me? I can't see your name. Molly. What is default subnet mask? Mishtala? Parimela? Shall I repeat? What is default subnet mask?
Identify the
Yes.
network position.
Identify the network position. How does it help to identify the network position? Okay, suppose this is my IP address. Now, tell me the position. See, default subnet mask is the method to tell our computer or to tell our uh, network interface card that which how many bits belongs to network and how many bits belongs to host, so that the network interface card clearly identify the host bit and the network bit, because this all classification of network bit and host bit is defined by a human being, but we need to tell our machine that which bit is belongs to whom. Am I clear? So if suppose this is my IP address and I want to tell my interface card that this is a class B IP address, I have to use some mechanism with the help of a NIC card can understand that this is these two are network octet and these two are host octet. So that concept is called default subnet mask. So it is, as I explained in the last session, it is very simple. Just convert all your network bit as 1 and convert all your host bit in 0. That will give you your default subnet mask. So if it is class B, it means it is network. So it will be 255.255.0.0. Similarly, if it is class C, it will be 255.255.255.0. Am I clear now?
Yes, sir.
Good. Okay. Moving forward, there is something called broadcast ID. Can anyone tell me what is broadcast ID? Anyone? What is broadcast ID? Okay. Let's suppose we have one IP address. Let's suppose this is 150.10.20.30. Right? So which class it is? Class
B.
B. Okay. Now what do I need to know? I need to know the broadcast ID. So broadcast ID is nothing but the IP address that we use for broadcasting purpose. And for any class, for every IP address, the last IP address of that range is known as broadcast IP address. Remember two things. Let's suppose this is one IP address 150.10.20.30. Okay, so this is my class B IP address in which this is my network, and host right? Now let's suppose I'm a IT guy of any organization, or let's suppose I'm a managing director of my company where I purchase this IP address, which is 150.10.20.20. What does it mean? It means that this part shows my network address and this shows my host address. So when I'm purchasing this IP address, it means my range of the IP could be start from network and the host can be from 0 to 255. Am I clear? Because I am purchasing this IP address means the entire range of the host, I can use the entire range of the host, right? So in every IP address, the first IP address belongs to network ID and the last IP address belongs to broadcast ID. Am I clear? Am I clear? Yes or no?
Yes, sir.
Let's take
Yes,
an
sir.
example.
Sir, repeat.
Yeah, sure. I'm giving you one example. So this is my one class A IP address. Let's suppose 11.200.200.200, right? So let's suppose I'm a MD of one company and I'm buying this IP address. So this is my network bit because this is network, host and host, correct? So it means my network starts from 11 and my first host will start from 0.0.0. So this is my first IP address, isn't it? because when I purchase this IP address, the entire host I can use in my organization. If someone else who is another company, they might buy 12.0.0.0. So the entire range of the host can be utilized by their employees. Am I clear? Am I clear?
Yes, sir.
So if
Yes.
this is my first IP address, what will be my last IP address? So the last IP address will be 11 dot, because this is one host only. This is the only one host. So the last host will be 11.255.255.255, because these are my host. Sorry, this is my host, and this is my network. So the next IP will be 12.0.0.0, which do not belongs to my organization. It may be used by another organization. So if this is the entire range, the first IP will be my network ID, and the last IP address will be my broadcast ID always. And rest of the IP addresses I can use for my host. Am I clear?
Sir.
Yes.
Yes, sir. Yes, sir.
Okay. So now, can anyone tell me if this is a class A IP address, right? So the number of network, number of hosts, okay, let's say number of network and number of hosts, or I can say, let's suppose this is, I'm taking the same example, 11.200.200.200. Okay, tell me number of, I think this you won't be able to answer. I will answer this question later. Now I'm using a class C IP address. So 192.168.0.10. Now tell me the number of usable hosts. Usable host means the IP addresses that I can assign to a host. So I'm explaining you. So this is a class C IP address. So it will be network, network, and network. So, and this is my host. So the first IP address, it means the first IP address of here will be 192.168.0.0. So this is my network ID. And if I say the last IP address, it will be 192.168.0.255. So this is my broadcast ID. So here how many hosts can be possible? 2 to the power 8. And 2 to the power 8 means 2 to the power 8 means 256. And how many IP addresses we have consumed in network ID and broadcast ID? 2 minus 2. So 254 will be my number of usable hosts. Am I clear? Am I clear, guys? So can you tell me the number of usable hosts for class B? Number of usable hosts for class B. So in the class B,
128.
so it will
128
be,
.0 .0.
let's take an example of 128 dot
0.0.
let's suppose this is the IP address. So here in the class B, host bit are 2 to the power 16 and 2 to the power 16. So 2 to the power 16 minus 2 will be my usable host. So 2 to the power 16 means it becomes 65,536. if I minus two IP address, one for network ID, one for broadcast ID, it will give me 65,534. This is my usable host, right? So this is for class C, this is class B, and if I say class A, so for class A, network bit is 2 to the power 8 and host bit is 2 to the power 24. So usable host will be 2 to the power 24 minus 2. So 2 to the power 24 become 16,77,700 216 and minus 2. So it will give you this much of host in class A. So that is why class A do have more users than class C or class B. Am I clear so far? So now we
Yes,
got
sir.
to know how to know the network ID, how to know the broadcast ID, and how to know the number of usable hosts in any IP address. And how can we tell our machine the class with the help of default subnet mask, right? Okay. Now I'm going to give you one example, one question. So 192.168.10.15. Tell me the network ID, broadcast ID, and number of usable hosts. Quick. No. I have already taken this example. I'm giving you the another one. 172.16.190.200. Tell me the network ID, broadcast ID, and number of usable hosts.
Network ID is 172.16.0.0 and the broadcast ID is
Sorry. Come again.
172.16.0.0.
0.0. Okay. Why it is 0.0? Because it is class
Class B.
Class B.
B. That's why it is 0. So it will become my network ID, right? Okay. Now what
Yes.
about the broadcast ID?
172.16.255.255.
Very good. This is my broadcast ID. And how many usable hosts?
65,534.
Very good. 65,534 because it is 2 to the power 16 minus 2. Right? Is there anyone to whom it is not clear? Okay, I believe it is clear. So let's move to the next topic, which is IP address subnetting. Okay. Okay. So can anyone tell me what do you mean by subnetting? Anyone? What is the meaning and what is the requirement of subnetting? In a very layman language or a very simple definition, what do you mean by a subnetting, or why do we need a subnetting? Anyone? Because see, unless until you won't understand the problem, you cannot understand and remember the solution. So we have to understand the problem first. Then only we can learn and we can remember the solution. Is there anyone who can just brief me in a very simple language why do we need a subnetting? Okay, let me tell you why do we do the subnetting? Okay, let's suppose I'm a company. This is my company where I have 4 departments. Okay, and in this department I have let's suppose 20 machines, 30, 5, and 10. Okay, Now, let's suppose I'm buying a IP address of class C. Let's suppose 192.168.10.0. This is the IP address which I am buying from INA. So how many hosts can be possible here? Number of usable hosts 254.
65,500.
No, it is class C.
Z2.
256 minus 2, 254. And how many network can be possible here? How many network can be possible? Only one. Because this is a class C and I'm buying this is my network bit. So this is my network ID, and here it can be only one IP address for network. So there is one network ID possible and 254 hosts can be possible. Am I clear? Am I clear?
Yes.
So it means with the help of this arrangement, I can create one network, and within this network, there may be 254 hosts, which is not my requirement, which is not the case, because I need four networks: network 1, network 2, network 3, and network 4. And in every network, the host requirement is very less, maybe 20, 30, 5, and 10. And if I talk about the maximum users, it is 30. So without subnetting, I have to buy 4 IP addresses. So the costing for this will be fourfold. So here I need to buy one network ID here. There will be, I'm just writing here. Suppose this is my IP network 1, 254 hosts. Second network, let me write here. Second network 254 hosts. Third network 254 hosts. Fourth network 254 hosts. It means here in network 1, 234 IP addresses are getting waste. Here 224 IP addresses are getting waste, and similarly here. Am I clear with the problem? So here we are wasting our resources and we are buying more IP addresses which is not required with the concept called subnetting. Am I clear with the problem? Yes, no? Or shall I repeat?
Repeat.
Okay. Class C IP address 192.168.10.0. In this IP address, network ID will be 192.168.10.0 because this is my first IP address. My broadcast IP address will be 192.168.10.255 because this is my last IP address. Number of usable hosts will be 256 minus 2, which will be 254, because here 2 to the power 8 minus 2. So it means with this IP address, how many network can be possible? Number of network will be 1 and number of hosts will be 254. So if in my company I have, this is my company, I need 4 networks with the 20, 30, 40 and 50 users. I have to create 4 networks here because these all are the different departments. So I need to buy one network here, another network here, third network here, and fourth network here. So if it is a class C IP address, there will be one network and 254 bits host, 254 host here and 254 host here and 254 here. So without subnetting, in order to assign a separate network and separate IP address, you have to buy 4 IP addresses. But here, if it is 20 IP addresses are using, 234 IPs are getting waste. Similarly here, 224 IPs are getting waste. Here 214 IP gettings are waste, and here 204 IP addresses are getting waste. So these all are paid resources. We buy these IP addresses from INA, and it is very costly. Am I clear with the problem?
Sir.
And the solution is subnetting, that we need to understand here, so that we can create multiple networks with one IP address only, and we can reduce the wastage of IP addresses. I do not say that we will completely avoid the wastage, but yes, we can reduce the wastage at a very large number, right? So shall I start subnetting?
Yes, sir.
Okay. See, subnetting are further two types. There are two. I would say there are two views to see the subnetting, to learn the subnetting, right? Today I'm going to explain you view one, and I will give you one exercise in which you will tell me the other way around of subnetting. But I will tell you the exactly what is the concept. You will learn the B method if you learn the A, right? So today I'm going to explain you subnetting A, and in the next session, for the next session, I will give you an assignment for subnetting method B, right? So subnetting can be done with the help of two methods. One is according to number of network required. This is method one, or you can say the logic one. The another logic is according to number of hosts required, right? Okay, let's make it other way around. Today I'm explaining you B method according to the number of hosts required, and I will give you assignment on according to the number of network required. Okay, you will just understand the concept right away. Okay. So let's suppose there is a organization where they have four departments. One is purchasing or procurement. There they have 10 hosts required. Excuse me. We have another department. Let's suppose production. There we have 30 users. Then we have another network, another department, maybe store. There we have 20 computers, and now we have another department where we have 40 users. And let's suppose this is my billing department or my marketing department. Okay, so these four networks are connected with two routers. Okay, so this is connected like this, and these two routers are connected with each other, right? So how many network you can see here? How many network required? Anyone? How many network required here? 4?
4. 4.
4? No.
2.
Sorry, 2 network? No.
3 networks.
Oh, sorry? Sorry, pardon? Here, we required 5 networks. See how? This is my network 1, network 2, network 3, and network 4. So in this network 1, I need one IP address that will be my network ID 1. Similarly, here, because this cable is connected with this switch, right? This is switch. So let's suppose this is switch. So the port which is connected with the router, I need to assign one IP address that will be my network ID. So similarly here, I need a network ID 2, network ID 3, and here also I need a network ID 4. But because these two ports are also connected, so I have to assign two IP addresses here. So that will be my fifth network. Am I clear? Am I clear?
Yes, sir.
Yes, sir.
Okay. So it means here we need uh, 5 networks, and if this is my network 1, network 2, network 3, network 4, and network 5, how many users in network 1? 10, 30, 20, and here it is 40, and here it is 2. Which network do have maximum users? Network 4, right? Okay. I request you please draw this network if you have a notepad and pen, because for the subnetting you need to do some exercise along with me. So you need to follow me when I'm explaining you the subnetting, right? So if you have a notepad and pen, just draw this diagram. Done? So here we have 4 networks, and network number 4 required maximum users. So in network 4 we need 40 users, and I'm going to explain you the subnetting for the class C first. So this organization procured one IP address of class C, let's suppose 197.10.10.0. So this is the IP address which is purchased by this organization for their network. Shall I move?
Yes, sir.
Very good. Okay.
Yes, sir.
So guys, here we have one IP address which is 197.10.10.0. Can anyone tell me the class of this IP address?
Class C.
Class
Class C.
Class C. So what should be the default IP address, default subnet mask? Subnet mask, sorry, let me write it. Subnet mask, default subnet mask will be 255 dot
255.0.
255
dot 255
dot 0.
So it means here we are telling the machine that this is my network bit, this is also network bit, this is also network bit, and this is my host bit. Because all my network bits will be 1 and all my host bits will be 0. Right? Okay. Now I'm going to tell you one another method to mention to express the default subnet mask. This method is known as CIDR value. So CIDR stands for classless intra-domain routing. CIDR value. So this is the one method to express the default subnet mask or the subnet mask. There is the another method to express the subnet mask, which is known as CIDR value. Okay, so CIDR stands for classless inter-domain routing. So if this is a class C IP address, the CIDR value will be number of network bit. So how many network bit we have? How many network bit we have?
24.
Correct, 24. So here the CIDR value will be /24. This is the another method to express the subnet mask value. So if it is class A, the CIDR value will be /8. If it is class B, it will be /16. If it is class C, it will be /24. Am I clear? So when I'm writing /8, it means 255.0.0.0. If it is /16, 255.255.0.0. And if it is 24, you know this. Am I clear?
Yes, sir.
Yes, sir.
Perfect. Moving towards the subnetting. So our IP address was 197.10.10.0. So what is the CIDR value? /24. So this is my default subnet mask. With the help of, I will tell the machine that this is class C. So take first 24 bit as a network and last 8 bit as a host. Okay. Now I'm going to tell you some steps to do the subnetting according to the number of hosts required, which is method 2. So if someone is asking to do the subnetting according to the number of hosts required, we will follow this method. So in this method, there are 6 steps that you need to remember, and it is very simple, right? So I'm going to tell you all the steps. You just make a note. So in the step number 1, convert all the host bit into binary. So in our example, host bit means the last octet. So it will be 197.10.10. Binary means 1234 1234. Am I clear? Step number 2. What is the formula for number of usable hosts? 2 to the power n minus 1. And n means number of hosts. Hope you remember. So for class C, it is 2 to the power n minus 2 means 2 to the power 8 minus 2. That is how we achieve 254. Hope you remember. So here we have to apply one criteria, that 2 to the power n minus 2. This is the formula for number of usable hosts. So the number of usable hosts should be greater than equals to number of maximum user required in any network. This is the second step. Means 2 to the power n minus 2 should be greater than number of maximum user required in any network. So can you tell me the number of maximum user required in any network? In our required network, what is the value of this?
$254.
No. In network 1, we require 20 users. Network 2, we require 30 users. Network 4, we required 10 users. Network 4, we required 40 users. And network 5, we required 2 users. Remember?
40.
So the maximum number of users required in any network is 40.
40.
Is this step is clear or not? It is very important step. So if someone is asking you do the subnetting according to the number of hosts, you need to know what is the maximum number you have to assign in any network. So if it is 40, we will meet this criteria. So now if suppose I put the value of n is equals to 1, it will be 2 minus 2, 0. If it is 2, 2 to the power 2 means 4 minus 2, 2. No. If it is 3, then 2 to the power 3 means 8 minus 2, 6. It doesn't meet the requirement, the criteria. 2 to the power 4 means 16 minus 2, 14. No. 2 to the power 5 means 32 minus 2. No. 2 to the power 6 means 64. And 64 minus 2 is 62, which is equals to 40. Am I clear? So it means as per this criteria, although I need 40 users, but in my subnetting network, in my subnet network 1, there will be minimum 62 users. Right? Okay, I will explain you later once I complete this. So now step number 3. So now I achieve my n is equals to 6. It means I need at least 62 users will be there in one network. So and 62 is more than 40, it is more than 30, it is more than 10, and it is more than 2. So it means it will meet my requirement. It should be greater than equals to number of, it should be more than this, it should not less than this. Okay. So now again write this IP address 197.10.10.1, 2, 3, 4, 5, 6, 7 and 8. What I'm going to do, just count 6 bits from right to left. So it is 1, 2, 3, 4, 5, 6. Draw a line here. What I'm going to do here, please understand that currently I have one network and how many hosts? 254. And subnetting, what is the meaning of subnetting? It is logical division of the IP addresses, logical division of the IP address, where I want to increase the network and I want to reduce the host. So how much I want to reduce? I want to reduce the number of hosts up to 62. Right? So in order to achieve 62 hosts in one network, I have to consider 6 bits in host. Remaining 2 bits I can give into the network so that I can increase the number of bits and it will reduce by number of host bits. This is called subnetting. Am I clear with the requirement? Suppose this is my network and this is my host. I want to increase the network bit. I have to shift this line here so that my network will increase and my host will decrease. That is called subnetting. So it is a logical division of IP address. And that is what I'm going to do here, that out of this 8-bit, which is giving me 254 hosts, which is not required, I'm borrowing 2 bits into the network. So when I borrow 2 bits, it will become 197.10.10. If it is, I want to borrow it into a network, my new IP address will be 197.10.10. Now it will, if I am borrowing into the network, I will replace it with 1. So it will become 11000000. So if you want to convert it this binary into decimal, this will be this one is equals to 128, this is 64, this is 32, this is 16, this is 8, this is 4, this is 2, and this is 1. Right. So if these two parities are 1, it means I just need to add these two values, rest will be 0, so it will give me 192. So this is my new IP address now. Am I clear so far? So in the step number 1, I just convert the host bit in 0. Step number 2, I apply this criteria where 2 to the power n minus 2 is equals to number of maximum user required in any network. So it is 40. So n will become 6. Means I required 6 bit in host, and rest of the bit I can give it to the network so that I can increase the network bits. So when I give it to network, I just need to borrowing bit will be become 1, and when it become 1, the new IP address will be this one. Can anyone tell me now the new subnet mask? What will be the new subnet mask?
26.
Very good, excellent. Earlier there was 8 plus 8 plus 8 bits in network. Now I borrowed 2 bits in network, so it will become 24 plus 2, 26. So this is my new subnet mask. So whenever you see any subnet mask other than /8, /64 and /24, you can understand that this is subnetting IP address. Right? Am I clear so far? Any question? If required, I can repeat this, because now we are going to do the subnetting and we will extract the new network IDs and new host IDs. Any questions so far? Any questions so far? No. It means we are good to go, right? Okay. So it means so far we achieve that new IP address is 197.10.10.192, and the new subnet mask is 26. Right. Park this IP address somewhere. Okay, so what was our original IP address? Our original IP address was that I procured from the INA. It was 197.10.10.0, and now the subnet mask will be 26. It means I'm telling my network interface card that here 26 bits are representing network and rest 6 bits are representing host. So now I'm going to do the subnetting. For me, the first subnet ID will be my first IP address, which is starting, because see, when I'm procuring 0, so 0 to 255, 0 to 255 comes under one IP address. So I'm the owner of that, so I can use it anyway. So it is 197.10.10.0 and /26. So this is my first IP address. So it will be my first subnet network ID. Okay. If I see the next subnet ID, which is my network 2, will be, can anyone tell me which will be my next IP address? My next subnet ID IP address? See, this is my first network. How many users can be possible in one network after subnetting? How many users can be possible in one network after subnetting?
64.
2 to the power minus 2 is greater than equals to 40 and n is equals to 6. So it will be 64. So I just need to add 64 here. So when I add 64, it will become 197.10.10.64 slash 26. So this is my network ID or subnet ID 2. So if it is my next IP address, so the last IP address means the last IP address of this subnet ID, it will be 197.10.10.63 slash 26. So this is my network ID and this is my broadcast ID. And if this is the network ID, then the first user will be 197.10.10.1. So this is my user 1. And if I say the last user, it will be 197.10.10.62. This is my last user of network 1. So this is my first network. Am I clear?
Yes, sir.
I'm just repeating for network 2. So how many users can be possible? Maximum user in one network 64. So I just need to add 64 here. So when I add 64, my subnet ID 3 will be 197.10.10.128 and the subnet mask will be 26. So if this is my third network, the last IP address will be 197.10.10.127 slash 26. It means this is my broadcast ID and this is my network ID. So the first user will be 197.10.10.65 and the last user will be 197.10.10.126. So this is my user 1 and this is my last user. Am I clear? Clear or not? This is the subnetting according to number of user required, where we know the maximum requirement of user is 40. Similarly, we can do it where we know the number of network required. So we will do the subnetting according to the number of network required and the number of user may be any. So can anyone tell me the third subnet third subnet ID and the broadcast ID and the first and last user? Anyone? Tell me
157.
the subnet ID for network 3. It will be 197 dot
10.
sorry 10.10
122 broadcast network.
sorry 1
122.
I'm not getting your voice. It will be 128 slash 26, right? And if I add 64, it will become, what is the fourth network? It will be 197.10.10.192. So this was our last IP, last subnet mask, subnet ID. So here the just before this IP address, it will be 197.10.191. So this is my broadcast ID of this subnetwork, and this is my network ID. And the first user will be .27, sorry, .29, and the last user will be .190. And if you count, you will get 62 users here. Guys, am I clear with this technique of subnetting?
Yes, sir.
So if it is clear, I believe you can do the subnetting for the next example. So I'm giving you one exercise. Okay, let's suppose we have the similar network where I have, let's suppose, 60 users in one network, 20 users in another network, and 10 users in third network, and 40 users in this network, and two IP address or two hosts required here. And the IP address is class A 12.0.0.0, where the default subnet mask is /8. So now you need to tell me, I'm giving you a few questions that I need the answer. So the first question is, tell me the first, tell me the, first of all, tell me the number of hosts in any subnetwork. So the first question is number of hosts possible in any subnetwork. That is question number one. Question number two. Question number two. Tell me the subnet ID 2 and its respective network ID, broadcast ID, and the first user and last user. That's it. Will you be able to do it? Guys, will you be able to do it?
Yes, sir.
Very good.
Sir.
Very good. So, shall we move to the next topic? So now I'm going to brief you the various headers of IPv4 and IPv6, and then we will start IPv6. Okay. So here we can see in this table, IPv4 is a 32-bit IP address, 8888, while IPv6 is 128-bit IP address. So we will understand the breakup, right? Next comes, it is a, here the header varies from 20 to 60 byte, where here the header is fixed 40 byte. There is no optional or variable bits available, while here we have 40 optional bits. That is how it becomes 60 bytes, right? Here it is separated by dot, while it is separated by colon. Okay, it is a octet value and this is the hextet value. Here the subnet mask represented in dotted decimal value like 255.255.255.0, or we can explain into the CIDR format, where here in IPv6 there is only method to represent the subnet mask in CIDR format. There is no dotted decimal method available. There is broadcasting supported, there is no broadcasting available. Loopback IP is this, here loopback IP is this. Okay, we use the default route is this one, the first 0.0.0, and here the default route is this one, colon slash zone, right? Then here we use header checksum while we do not use header checksum. There are four classes where ABC is used for unicast, D used for multicast, and broadcast. Each domain has its own broadcast address that we already discussed. While in IPv6 we have unicast, multicast, and anycast. There is no broadcast. So this is the just a basic difference between IPv4 and IPv6. Now we will understand the formatting and the header structure between IPv4 and v6, and then we will start IPv6 and its subnetting. Okay. So as we discussed, it is a IPv4. It is a 32-bit addressing. So in the IPv6, if I draw the header, it will look like this. So there are 7 columns. Right. So all are 32-bit. These all are 32-bit in IPv4. So in this, the first 4 bit tells about the version. So if it is 4-bit means so out of 32, the first 4-bit tells about the version. It means it can be 0000, 0001, and 0010, and so on. So if it is IPv4, so it is 0, 1, 2, 3, and 4. So if it is 4, it will be 0, 0, what will be the value? 1, 0, 0. So this is how it will become 4. So if it is IPv4, it will carry this value 0, 1, 0, 0. If it is IPv6, it will be 0, 1, 1, 0. So this is how it tells to the node whether we are using IPv4 or v6. Right. So the first 4-bit represent the version. Then remaining 4-bit talks about the header length. So out of this complete packet, how many bits we have used in IP header? So we call it a IP header length. So 4-bit represent the IP header length. Then the 8-bit, remaining 8-bit talks about the type of service. So here type of service is very important field which tells about which kind of payload or which kind of traffic we are carrying in this IP packet. So it is represented by the help of with the help of type of services, right? Then the remaining 16 bits talks about the total length. So it is tells about the total length of this packet, including the PDU as well as header. So this is how the 32-bit filled. Into the next row, the 16 bits, gives the value about the identifier. So it is identifier. Then 3 bits here for flag, and the 13-bit is for fragmentation offset value. What is that? I will just explain you. Offset value. Okay. So hope you remember. Can you tell me which layer read or which layer understand the IP address? Which layer do it? Layer 3, right? Network layer. And what is the function of transport layer? Anyone? What is the function of transport layer?
Segments packet.
Very good. Segmentation and concatenation. So this identifier tells that whether this packet is segmented or not. Am I clear? So this identifier tells whether this packet is segmented or not. If it is segmented, the flag value tells me, let's suppose this is my complete packet which is segmented in 4 parts, right? So this flag will tell me this is 1 by 4, 2 by 4, 3 by 4 and 4 by 4. It means there are 4 segments that need to be concatenated at the receiving end. So this flag tells me about this value. Am I clear? Next is fragmentation, fragment offset, 13-bit. Okay, so fragment offset, please mute your mic. Please mute your mic. I'm getting my voice back. Thank you. So fragment offset, uh, do you know what is the function of a router? What is the function of a router? Router basically works in 3F: forward, flooding and filtering. I will explain you later. So one router is capable to do the segmentation again. Right. So one router is capable to do the segmentation. If a router is not able to fill that complete traffic in one packet, the router can do the segmentation again. So this fragmentation offset tells to the router whether you can do the segmentation again or not. If suppose there is some critical information which is not allowed to do the further segmentation, the offset value tells to the router whether you are allowed to segment for further segmentation or not. Let's suppose there is a situation where the router is not able to put that data into the transmission line without segmentation. In that case, it will check the fragmentation offset value. If it is allowed, router will do the segmentation. Otherwise, if it is not possible without sending, router will drop that, which is comes under the filtering. Right. So fragment offset value tells that whether you can do it further segmentation or not. Next come time to live. We call it TTL, time to live. So here we have 8 bits for time to live. What is the meaning of time to live? Let me draw another small diagram. Let's suppose this is a network and there are 3 routers. Okay, there are 3 routers and it is connected like this. Okay, so what is the how the router works? Router works on a routing table, right? And with the help of that routing table, the IP address identify the shortest path, right? So let's suppose one IP packet starts from this source with this host and it reaches to this router, and this router tells that this is the shortest path. So packet will reach here, and this router, and let's suppose it is connected like this. This router will tell that this is the shortest path, the packet will go here, and this router again tells that this is the shortest path. So router will again packet will again reach here. So it will create a loop, and the packet will stuck in this loop, and it will cause the congestion into the network, and it will choke the entire bandwidth of the transmission line. To avoid this situation, we use TTL, time to live. So here we use the time to live bit is means 8. It means 2 to the power 8. It means 2 to the power 8 is 256. It means in any communication, in any internet network, there may be maximum 256 routers. How does it work? Now let's suppose the TTL value is 3. It means there may be maximum 3 routers. So when it pass first router, it will append this value as 2. Now it will reach to the second router, it will append the value 1. Now it reach to the third router, it will append the value 0. And then if it doesn't reach to the destination, it means now it is still there is a routers available. So in that case, it will discard that packet and it will ask for the retransmission so that it will not create a congestion into the network. So if I'm saying that maximum number of bits can be 8, it means in any network there may be maximum 256 router in any network. So if you want to check how many routers available, if you are pinging to Google server, just check the number of router with the root trace, right? And it will show you how many routers are available between you and the Google server. It would be around maximum 10 or 16, 10 to 16. But how many routers can be possible? 256, because the TTL value is 8, right? Next is the another 8 bits tells about the protocol type, which protocol we are. Oh, I lost the diagram, so let me explain here. Okay, here I have the protocols. So the protocol means whether we are using TCP protocol or UDP protocol. So it is 8-bit, TTL is by 8-bit, and protocol is also 8-bit. Header checksum. So here we can see it use header checksum. So here we have 16 bits for header checksum, which checks the header whether we are using the checksum value. So it will check whether the at the receiving end the transmission is correct or not. Then we have 32-bit for source address and 32-bit for the destination address. Remaining 40 bits are optional that we use for a specific purpose. So these field cap, it is not there in IPv6. So these are the optional bit that we can use according to the network requirement. So am I clear with the headers of IPv4? So here 32 bit for the host, so source, and 32 bits for the destination IP address. Am I clear with this? Shall I start IPv6? It is very simple. You can, if this one is clear, you can comparatively understand IPv6. Okay. So in the IPv6, as I mentioned that it is 128 bit, 128 bit. So in IPv6, there are 4 rows. So the first 2 row is 32, 32, remaining 2 are 128, 128. Right. So the first bit again talks about the version similar to IPv4, right? Similarly, 8-bit tells about the type of service, or we actually call it a traffic class instead of traffic instead of calling it type of service, we call it a traffic class, right? Then we have 20 bits. So here it is 8-bit. So here it is 8-bit. So 8 and 12. So remaining 20 bits we use for flow label. So flow label is nothing but the flag that we use for identifying the segmented part. Okay, here 16 bits is for payload length, size of the PDU, right? And then 8-bit is for next header, and remaining 8-bit talks about the hope limit. So hope limit is nothing but TTL, time to live in IPv4. Concept is exactly same. Okay, then here 128 is my source address, and this is my destination address. So this is 16 byte and this is 16 byte. So this is how it is: 4 byte, 4 byte, 16 byte, 16 byte. So it become 40 byte address in IPv6. So comparatively, you can easily understand here. Same version, type of service is represented by traffic class, right? There is no header length, because see here header length is variable because it depends on this optional field, and in IPv6 we do not have optional field, so that is why we need not to tell the header length, because this header length is depend on this optional field, right? So it is remove this part. Next is the flow level, which is related to the flags. Payload length, so it is here the total length is payload length. Next hope is the next IP address, and hope limit is nothing but time to live, and this is the source address and destination address. Am I clear? Any question? Shall I start IPv6? Subnetting of IP. Okay. So guys, I'm not getting any feedback, any acknowledgement. I'm not getting whether you are understanding or not. If it is not clear, please tell me, because I have multiple method to explain the same topic. If it is not clear, please acknowledge so that I can use the another one. So it seems it is clear so far.
Yes, sir.
Perfect. So let's start IPv6. So as I already mentioned that it is a hexstat value, hexadecimal value. So now we need to understand how do we convert the hexadecimal value in binary format. Okay. So before that, we need to understand the formatting of IPv6. So let me open the IPv6 slide. So here it is. So in IPv6, as I mentioned, 128 bits available, right? And there are 8 fields. This is first field and this is the 8th field, right? So there are 8 field, and if 128 divided by 8, it will give me 16 bits. So it means 128 bits divided in 8 groups, and each group do have 16 bit, 16 bit, 16 bit, and so on. So now in order to convert this 16 bit into the hex value, it will become 4 hex values, because one hex value represent 4 bit. Am I clear?
Yes.
So let me just brief you. One hex is equals to 4 bit. Okay. So 4 hex value will become 16 bit. Right. So how many how many fields we have? 8 fields. So if one field having 16 bit, it will give me 128 bit. Right. Okay. So as we already saw that the separator is colon this time instead of dot. So in IPv6, every field is separated by colon. Okay, so this is one of the example of IPv6. Right now, I there are some rules to read the IPv6 IP address. There are 3 rules basically. Okay, what is the first rule? First rule says that if we have continuous let me tell you in this way, that let's suppose we have uh, first in the 4 hexadecimal bit, if the first bit is 0, if the first bit is 0, we can remove it. So this 09C0 will become 9C0. So it is self understood that if there is 4 hexadecimal value, it means the fourth hexadecimal will be as a prefix. So it means 9C0 is equals to 09C0. That is the rule number 1. Right? So if there is 3 hexadecimal values or if there is 2 hexadecimal value, it means it will be 20. Right? That is rule number 1. Rule number 2. If we have successive fields are 0, we can represent by colon. It means here you can see, so here you can see here 4 zeros are representing by 1 0. So if there is 1 0, it means it is 4 0. Okay, that is rule number 1. Rule number 2 says that if successive bits are 0, you can represent it with 2 columns. So here you can see it will become 2031, 2031. 40 will become 10. It will be as it is. Will all 1010. It will 1010. It will be 3 digit 9C0 and so on. So now here you can see this is leading zeros and it will be replaced by 2 columns. But we cannot use double column twice. It will be only used one time. So this is okay. This is not okay. We cannot has twice IP in IPv6. It can be one. Am I clear? Am I clear?
Yes, sir.
Okay. So now I'm giving you one example of IPv6. What is the meaning of this?
40.000.0000.
Yes, it means and so on up to another 3 fields. Okay, now let's understand how do we convert the hexadecimal in binary format. Okay, so it is very simple to do it. Just remember 8421. Okay, just remember 8421. Okay, now I'm giving you some hex value. Let's suppose 26AB. So as I mentioned, each hex value will represent 4 bit. So if it is 2, how can I get 2? It will be 0010. What about 6? 0110. And in the hex value 0 1 2 3 4 5 6 7 8 9 A B C D E 9 10 11 12 13 14 and F. So if it is A means
1010.
10. So if it is 10, it will be 1010. B means 11. 11 means 1011. Am I clear?
Yes, sir.
Okay, then do it for FA87.
4 ones, 10,
4 1 1 2 3 4
1010,
1010
100.
1000.
and 031.
Yeah. So 7 means 8421. So all 0, 1. So it will be 0111. Is it clear now?
Yes, sir.
Will you try again? Okay, do it for FA BD 1986. Now do it for this. F means all 4. A is equals to 10. 8421. If it is 10, it will be 1010. What is B?
9.
B
1001.
71011.
0. B is 11. 11 means 1011.
11.
D. D means
13.
30.
13.
And 13 will be
1101, sir.
1101.
1101. Very good. Similarly, if it is 1, then it will be 0001. For 9, it will be 1001.
1001.
For 8,
1000.
1000. For 6, 00. No, no.
No,
0.
0.
Sorry. 0, 1.
0110.
10.
So this is how we can understand hexadecimal values. Okay. Okay. So moving forward, so as we discussed in IPv6, there may be unicast, multicast, and anycast. So unicast we use for the global unicast address, local address, and linked local address. So these are the use. It is used for scope in global local address we use within the site or the within the organization, not routable over the internet, and link local address, that is within the segments or not routable, and global unicast we can use over the internet, multicast one to many, anycast one to nearest allocated to the unicast address. Now we are going to understand the subnetting of IPv6. What is the purpose of subnetting? What is the purpose of subnetting?
To reduce the number of users.
No. Sorry, my bad. This is the wrong question.
Yeah,
Tell me what is the use of default subnet mask?
To know the number of network bits and
Very good.
hosts.
Very good.
you know the number of
Very good. So default subnet mask tells the network bits, right? So in IPv6 we have 128 bits. So by default 64 bits represent network and 64 bits represent host. So if you see any IPv6, you will find default /64 means it is representing my network bits. So it means default subnet is 64. So in the default, 64 bit represent network and 64 bit represent host. Right, now let's talk about subnetting. Now if suppose we want to reduce the number of bits and we want to increase the number of hosts, we can borrow some fields into the host. So if I'm just borrowing 16 bits into the host, then it will become 48 bits. So the new subnet mask will be /48 or slash, if I borrow another 4, 44 and so on. It is as simple as in IPv6. Am I clear?
Yes.
So that's the same concept we use in the MAC address. So in the MAC address, it is the 48-bit address that we use for the MAC. It is also a hexadecimal value. So in that, the first 6 octet six hexadecimal values represent OUI or organization unique ID, and the remaining 6 hex value represent the vendor ID. Right? So this is how we can identify the MAC address. So this is all about for today. And any questions so far? Any questions so far? Anyone like to add something? Okay.
Sir, in previous class, if we change the IP address once, means it will remain there forever or it will change, sir?
Sorry, pardon.
If we change the IP address, will it stay there forever or it will change automatically after some time? Or
Okay, it depends whether you are assigning the IP address statically or dynamically. So let me show you. I explained in the last session also. Let me show you something. So suppose this is my network setting. So here, if you look at my Ethernet setting,
sir, PPT is visible.
no, I'm sharing my screen. Can't you see my screen?
No, sir.
Yes, visible, sir.
Just a minute. Let me close it and share again. Is it visible now?
Yes, sir.
Yes, sir.
Okay. So if you look at here, I've assigned the IPv6 address automatically. So it will be a dynamic IP address and it will change according to the DHCP server, which is configured somewhere, and that DHCP server is allocating the IP address, and this IP address will not remain same. It may change. Okay, but if I use this option, which is use the following IP address, which will be my static IP address. This is for IPv6. Similarly, I can show you for IPv4. So here you can see I have selected the dynamic IP address. So it will be automatically. Am I clear? So if I choose this one, it will use my static IP, which is mentioned here. Am I clear?
Yes, sir.
Yes, sir.
So in the next session, for the next session, there is assignment. You will check the subnetting according to the number of network, and I will consider one example, and we will discuss that. Okay.